Good morning, Mark Peacock, Executive Secretary, Project Haystack, back with you. We hope you've enjoyed the first 2 days of Haystack Connect. Think we're going to rest because it's day 3? That'll be a big no, a big nada, negatory. We've got a lot coming up, including more fantastic Track 1 and Track 2 presentations. But first, it's Pitchfest time, guys and girls. Pitchfest is a fast-paced look at new offerings and services utilizing Haystack methodology. We call it our Shark Tank for the data world. Presenters are given 10 minutes to make their pitch, and we'll be strict on that 10 minutes. To introduce our participants and preside over Pitchfest, let me introduce John the Hammer Petsy and Haystack's Executive Director. John, take it away.
All right. Thanks, Mark. Thanks, Mark. No, this is just a really exciting session. Really enjoy it ever since we introduced it. It gets back to the point about the community, right? It's a community that develops Haystack. It's also the community that develops tools and applications and products around it. And Pitchfest has turned out to be a very successful part of the conference where companies with new technologies, whether they're open source and no charge or they're commercial products, they get to pitch to the audience. And as Mark said, it's 10 minutes. We have to maintain a strict time on this so that it's fair for everybody. So looking forward to these presentations and this fast-paced session. So thanks for joining us this morning. All right, well, let's get started. First up is Emma Einen, Director at Phantom Factory, and she's going to present how can I learn to use Project Haystack tags. And her presentation is a video that was submitted. Emma's company is based in the UK. So roll for Emma.
Trying to learn how to use Project Haystack tagging standards from the very beginning can often be quite a challenge. So I'd like to present to you how our e-learning at Phantom Factory can easily help anyone new to get started. First of all, let's meet Chuck. Chuck is an energy engineer and it's his first week in a new job. His new team uses Skyspark to manage the data in their smart buildings. This week, Chuck needs to learn Skyspark fast. But first of all, it's important he's able to understand and use basic Haystack data tags. He's been directed to the Project Haystack website, which to be honest can seem a bit overwhelming. Lucky for Chuck, Phantom Factory is here to help with online e-learning. Chuck's discovered our website training platform, the Alpha Colony, which we've especially built in Phantom to deliver our e-learning courses. Well done, Chuck. You're on a mission to Mars. Welcome to the Alpha Colony, based on Mars. This is where Phantom Factory's interactive e-learning takes place. Using scenarios and hosted data for training exercises at the Alpha Colony gives a clean and simple environment to help with easy to understand and applied learning. Gamification is recognized in the training industry as an excellent way to learn. And so our e-learning content is designed for maximum engagement and interaction. Although, if some learners find the extra content is just too distracting, there is also the option to switch the story mode off. After all, everyone has a different learning style, and as an excellent training provider, we want to help our students learn in the best way for them. Now, as Chuck has just discovered, our new Skyspark Engineer e-learning course is a great way to start learning about Project Haystack. We teach the basic concepts of data tagging, the benefits of using Project Haystack standards, and how to use the reference material on the official website. As we build our first project in Skyspark, we also provide detailed reference links and explanations of Haystack tags and data types as we apply them to our new records. Learning about Project Haystack tagging is an important part of understanding more about data integration, especially for a technology such as Skyspark. In fact, our Skyspark Engineer e-learning covers everything you need to know to build a first-time project. Using our example Arcadia project, we use just 6 points to demonstrate the key concepts behind understanding Skyspark data structures, Project Haystack tagging, project building and records, filter expressions, databases and storage, using connectors, writing values and managing history data, and even writing rules. At Phantom Factory, we provide everything our learners need within our digital content, using interactive exercises and even our own hosted Skyspark instance. For our Skyspark Engineer students who have access to their own Skyspark installation and would like to practice the project building exercises for real, we've worked hard to create some exciting bonus training material. We've created the Arcadia Toolkit, a free Skyspark extension which provides ready-made Axon functions and a record loader tool to automatically reset your project data to each training level. To use it, you just need read-write access to your own Skyspark installation, an empty training project, and an available license capacity of just 10 points. For anyone looking to simply try Skyspark out, this is a convenient and affordable way of using a small, basic Skyspark project for the first time, and with guided instruction. Chuck may be an engineer, but Phantom Factory's e-learning range is designed for anyone new to Skyspark and Project Haystack who may need to understand tagging, data analysis, data integration, or even Axon. So now, Chuck can get up to speed with starting to use Project Haystack and Skyspark all within his first week at work. As a recognized training provider of excellence, ask us more about our internationally recognized program for continued education or continued professional development. I hope you've enjoyed this short presentation about our new e-learning course, Skyspark Engineer, and how this helps to teach the concepts of Project Haystack tags as they apply to a real data analytics platform like Skyspark. My name is Emma Einen, and please feel free to contact me or my team if you'd like to know more. Phantom Factory, where learning is understanding.
All right. Well, thanks to Emma for submitting that. And now we're going to move on. And Anto Bugiardo, CEO of Paddy, is going to present a live working example of integration using connection profiles. You may note that he spoke about the concept in one of the technical sessions yesterday. And now we're going to see a demo of the Paddy tool doing a working integration. So Anto, are you ready so that I can start the timer?
I am ready.
All right. You now have 10 minutes.
Okay. Thank you, John. Hello, Haystack. So working integration using connection profile using Paddy. So what I'm going to be doing is I'm going to be building a small hierarchy, starting off with a team and a building and a couple of spaces within the building. I'm going to do this in Paddy. And then what I'm going to do is I'm going to install an app. We have partnered with Novant, which is a company that's also at the Haystack here, to create a Novant server. So we're going to install that and show you how that's done. And then we're going to install a client, there's also a Novant client, that will then automatically connect to that server. And that's the whole sort of connection profile mechanism that I talked about yesterday. And then we'll add another client just to show that it's scalable and potentially do some other things if we have time. With that, I'm going to head over to Paddy. So Paddy is open here on another tab. I'm going to create a new team. So I'm going to say I'm going to create a team called Haystack. 21, just call it that. I'm going to ignore the rest of this information for now. So we now have a team called Haystack 21. Just to make things a little bit fun, I'm going to add Andy Frank to be part of this team. So I'm going to invite him, join me. I'm going to make him an admin, and that's going to go over to him so you can actually see that's happened here. All right, so in Haystack 21, I'm going to add a collection. In PADI, a collection is basically like a folder. So I'm going to create that and I'm going to call it building. Just do that, ignore the rest of the stuff. So now I have a building, and inside that building, I'm going to create another collection, call that lobby. And I'm going to add another collection here. Actually, no, I did that wrong. I'm going to add another collection underneath building, and I'm going to call that boiler room. Do that. Mistyped. Okay. So now I'm going to open up the building. So we now have building here. And what I'm going to do is I'm going to add this the Novant server. So I'm going to add it here in the tab. It's not one of the standard applications. It's a specific application called Novant server. Okay. So when I'm adding the Novant server, it's going to need to know a few things from me. It's going to need to know the URI of the server. So to do that, I'm going to head over to Novant's support website and fish out the URL for that. I'm going to put that in there. Request method, I'm going to just sort of put proxy, which is what we're doing here. And then there's an authorization code, which is really the API key that is part of Novant. So I'm heading over to Novant. I'm going to go to the API key section. I'm going to copy that and put that in there. And it also needs a colon at the end. So I'm going to do that. And I have the Novant server now installed. So I have a Novant server installed there. At present, the Novant server does not have a UI, so it's pretty bare, but it's there and it's working. And what I'm now going to do is I'm going to go to lobby, and I'm going to add inside that lobby, I'm going to add a client. So to do this, I'm going to select the Novant client, which is this one here. And what this is going to do is it's going to connect the client with the server. You can actually see it's already found the server. That's part of what Connection Profile does. But to configure the client, I need a couple of things. I need endpoint, which is really the information that's going to be requested. So I'm going to call this points. And I'm also going to need to tell the client which device to get that the points information from. So the format of that is device ID equals. And I'm going to go to back to my Novant, and I'm going to go here, and I'm going to pick up this device ID. One of the things that we're working on with Andy Frank at Novant is to actually automate this so it becomes a lot easier. So I've added what I want out of that Novant server and which device I want. So I'm going to install that, and I'm going to call this I'll call it points. Just to give it an identifier. And if I now open up the lobby and go into the points, you'll actually see the data. So this data is streaming across the internet from the server that I installed to this particular application. In this scenario, the application is pretty basic, just displaying the JSON. But the whole idea is that this client could actually be a graphical dashboard or an analytics suite or something, but it's actually just getting the data from that building, the Novant server that's installed there. So I'm going to do one other thing. I'm going to install another client. Where to go? This one here, and it's going to go through the same thing, the same process. The endpoint, I'm going to say I want values now, which is another option. Device ID equals. I still have it in my clipboard, and I'm going to just call it values here and install that. Right. So again, in the boiler room, I can open it up and I can look at the values, and that's actually again getting the values out of the server. And just to prove that, I can actually go back to the building level and look at the Novant server, and now look at the connections that it has. And it will. This is the same information as before, but you can actually see now it's actually connected to two clients. The values has this requesting values and the points requesting points. Right, so that's basically the process. Andy is also joined there, so he can actually see all of this, and he can actually see those values flowing in exactly the same way that I did. Going back to the slides, really this is what we did. This is what's behind the scenes. I'm on the browser. PADI is obviously there. What I did was I installed a server, which is an instance of a Novant server. All right, so this is all in PADI, and then I installed client 1 and client 2 that are actually connected to this client app. Right? And the important thing to note is that the data flow is directly between the Novant client and the server. So it does not go through PADI at all. It does not go through Connection Profile Broker. And so using this mechanism, you can create apps here, and your apps would just be basically HTML pages that gets embedded into PADI. But using Connection Profile, we will then connect that app to, let's say, the Novant server, if that's the server you want to get to, in this exactly the same way that this client does. And your app could obviously do whatever functionality that you need. And if you're looking at it from the perspective of having a server, then it will be replicating what we did with Novant server, so that you can have a server that serves up information using certain profiles, connection profiles. The connection profiles are the things that establishes these connections, which then establishes the connections between the real entities. So in a few minutes, we use PADI and connection profiles. We installed a server. We installed and configured a couple of client apps, and we saw information flowing across the internet. So that's really what Connection Profile is all about, is to make integration between systems easy and quick and scalable. And we believe we do that. And the call to action here is that there's obviously an opportunity to create some Haystack connection profiles. So the communication going between clients and servers can actually use Haystack REST APIs, as well as using tags to actually then filter out what you actually want to flow across the internet. I invite you to come and join me. We do office hours every Tuesdays at 3 p.m. Eastern. If you want to register and come and join me on that, head over to join.padi.io, and you can see all of the details, the Zoom information, and everything else. So with that, I'm done. Well under 10 minutes. Thank you.
Wow, you beat the buzzer there. Fantastic. Thanks, Anto. It's definitely great to hear more about the whole connection profiles and see it in action. That was a really interesting presentation yesterday, so thanks for that. All right, so next we're moving on to Felipe Prados. And Felipe is a data scientist and architect at NG Digital and Octo Technology. And so Felipe is going to present via a video. So it is time to roll video for Felipe.
Hello, I'm Felipe Prados at Octo Technology, and I will present a new open source component to help to implement the Haystack specification. So, Sheet for Haystack, it's a new open source component. Thanks to Andy for financing this project. It's a new Python module to implement the Haystack specifications. With this module, you can read or write a Haystack file. You can implement the Haystack HTTP API. just with a new Python class, extend an interface and implement the method like this, like read, when you can see here. And we propose different providers to implement the possibility to save and request the ontology from the different backend, from URL, from SQL database, or from Mongo. And for each provider, we propose a model to save the entities and propose a strategy to convert the Haystack filter to a specific SQL or Mongo request. And we exploit the different specific syntax to manipulate the JSON in database. The implementation of JSON in database is different for each version. And we propose a GraphQL API. To do that, we must have just two major variables, Haystack provider, to select which provider we would like to use. And another variable is HaystackDB, and with variable, you can just select URL connection to the database or to the backend. This code can be convert the Haystack filter to a specific SQL or MongoDB request. We have a tools to show the difference for the different databases. For example, at the top you can see the SQLite versions to convert the filter A or B, and you see its difference with the Postgre versions, because these two databases use a different approach to do that. But you can convert that for MySQL, Postgre, SQLite, or Mongo, or use with a file or from HTTP or from S3 or what you want. We propose a generic Haystack client interface. This interface can just communicate with the Haystack HTTP API, and the user interface knows only three tags: IDs, dis, and ist. And it's possible to set a different API at the same time, and all the results are merged in the user interface. And we propose a GraphQL interface too. I would like to publish some ontology to Bacnet and publish a lambda to expose this ontology. So this is a file I would like to publish. The ontology is here, and the associated history are in other files. So I can check if my bucket is empty. Yes, it is. Then I begin to import this ontology and the associated history inside the bucket. Okay. Now the bucket has this file, and now I would like to publish lambda. I customize this file with the regions, the project name, or some other parameters. And very important, I select a provider to use the file from a bucket and the link to the data. And now to publish this lambda, just use Zappa deploy. Okay, so I can test this URL. Yes, I have two links, one for the Haystack API and the other for the GraphQL API. Here, I have a user interface to manipulate the Haystack API. And it's started with himself. Here, I can see the graph with all the entity and the relation between the entities. Here, the different tags with different value. If it's possible, I have the history values. And I can use a filter to select only some entities, like weather, like only the entities with the time zone is Paris, or maybe more complex, like Equipe Wolfe limited with Wolfe Paris, and I have two results, but some results have a link to other entities, but we don't know which one. I can see here the name of this link, and it's possible to navigate between these entities. You can see here I add a filter with ID. Okay. Okay. Now I would like to add some entities, but in a MySQL database. So to do that, I start to add in the environment the modules to manipulate MySQL. Okay. Now I can set a variable with a link of this local database. Okay. It's time to import the data inside this database, this MySQL. And now I can start this a local Haystack API with a link to this database, to this MySQL database. Okay, it started locally with this URL. I can use this one to add a new URL. And now all requests can merge with this different URL. So it's possible to merge the result from different API, Haystack API. You can see the different color for this different value. And I can use the filter, the same filter like before, and this filter is convert to a SQL request to use the SQL database to resolve this request. We need you, because at this time it's not a Broadway project, it's just the first public versions, just for this Haystack Connect. You can see all the project and all the code in one link, or check Shift4Haystack in GitHub. And we need you to open ISU, to fork me, to propose some pull request or what you want.
All right. Thank you, Philippe. I appreciate that presentation on ways to simplify implementation of Haystack and the call to the community to help with the further development of the tools. That's what this is all about. All right, well, next up, we have Scott Muench, Vice President of Customer Experience at J2 Innovations, and Jeremy Wolfe, Vice President of Sales Americas for J2 Innovations. And they're going to share a pitch on microBMS, a demonstration that includes cloud to edge connectivity. So, gentlemen, take it away. Your timer will start as soon as I see your screen.
Thank you, John.
Thank you, John. Hello, this is Scott Muench with J2 Innovations. Today, we'd like to pitch a new application suite called Fin microBMS and Edge to Cloud. By combining the power of the Fin framework and Haystack tagging, you can have the benefits of efficient, comfortable, smart connected buildings without the cost and complexity of traditional building management systems. Whether for small offices, retail, or school buildings, Fin microBMS provides just the right functionality with intuitive dashboards, reporting and analysis, all deployed with a simple plug-and-play experience. Now let me introduce you to Jeremy Wolfe, our VP of Sales for Americas, who will show you how easy it is to configure a typical microBMS project. You'll then join that site live to the enterprise via secure cloud connection for remote viewing and access. Here you go, Jeremy.
Thank you, Scott. Here we're going to use the Fin commissioning wizard called microBMS Builder, which is a series of steps to automatically build out your project. You'll see that I've pre-filled the building information with the name, address, square footage, and number of floors. So we can simply click the forward arrow and move on to step 2. We can select the number of floors by using either the slide bar, inserting the number, or selecting an up or down arrow. We're going to select one floor, and we're going to proceed forward. Now in step 3, we're going to add equipment. We can add lights, we can add HVAC, and we can add meters. We can also edit the name of this by selecting the edit pencil. As we move forward to the next step, based on whether we selected lights, HVAC, and meters, the system is going to load all the available templates that are associated with those types of devices. So as we proceed to the next step, we'll see these available templates to select from. We're going to go ahead and select all of the available templates, and then we're going to click the forward arrow to move to the next step. In the equipment configuration, we can assign the specific templates that we have here to the devices. This step can be automated, and we can skip some of these in certain scenarios. But I'm going to go ahead and select a template for the lights, for the meter, and also for the HVAC. And you'll see here you can also edit the names of these devices with the edit pencil. Lastly, we're going to be asked to provide the device ID and IP address. You'll notice in the upper right-hand corner that there is a discovery tool. This automates the process. So we're going to use this online discovery tool to go ahead and fill in the device IDs and the IP addresses. And then we're going to select the forward arrow to move forward. Now this is where all the magic happens and everything gets loaded. So we can simply click on the checkbox and go to our newly created project. So as we look at the dashboard, you'll see that the information we inputted in the builder is nicely represented as tiles. All these tiles are interactive, meaning that you can select any of them to reveal more data. As I select the alarm, you'll see that the corresponding button on the navigation panel is selected as well. So on the navigation panel, we can dive into HVAC, we can get into the lights, and we can look at meters as well. We can also take a look at the maintenance screen, which provides an opportunity to make notes or even open and close tickets. If we go to the upper left-hand corner, you'll see an app icon. This opens the screen with the different applications like air quality, energy. We also have gas and water. By selecting the reporting app, you're going to be provided with an overall view of the status of your site. And you can select either weekly, monthly, or yearly reporting. And these can be exported to PDF, Excel, they can be sent by email. And the calendar icon also allows you to schedule reports and for them to be sent automatically. Scott had also mentioned edge to cloud. This allows you to manage different organizations and lets you tunnel into the customer sites using Haystack over MQTT. By zooming in and selecting a site, you'll be presented with an overall view of that project. In addition, you can securely remotely access the site by selecting the remote access. So we are now working remotely at the on-site device, which provides the same functionality as if we were on-site without the need for VPN or complex IT configurations. So now I'll turn it back over to Scott.
Thank you, Jeremy. That was awesome. So that's our live demonstration of Fin microBMS for small commercial site implementation. We walked you through the guided engineering and the provisioning process, culminating in a completed project with dashboards, reporting, and control. The use of Haystack tagging has been utilized to create a plug-and-play environment where the wizard gathers the data and then associates it with tags to reduce the overall skill level needed to engineer and deploy a project, therefore expanding the addressable market for intelligent buildings. These connected sites were then combined with our edge to cloud technology to provide a global view and remote management of the sites. We hope that you'll consider Fin microBMS as an enabling technology for your next product. Please feel free to reach out to Jeremy or myself if you have any further questions.
So Scott, we've seen a lot of talk today about the Haystack tagging. How does that tagging play a role in what we just saw with Fin microBMS?
Yeah, it was kind of that magic that you mentioned in the microBMS wizard. Behind the scenes, we're creating bindings using the Haystack tags and also data models to feed those templates. When those are combined and they come together, we get relativized points, relativized graphics, and then those can also go to the next level, which can then be relativized for control sequences, for smart alarms, for fault detection and diagnostic. So enabling technology not only at the site level, but also to the cloud, where we're using the Haystack protocol to transfer that data, make those queries, and bring that up to the next level in our edge to cloud solution.
Thank you, Scott.
Thank you. Back to you, John.
All right. Thanks, Scott. And Jeremy, we really appreciate that presentation on a really interesting application for smaller facilities. That's great. So, all right, well, we're going to continue on. Next up is Jean-Simon Venn, co-founder and CTO of Brainbox AI. And the presentation is on automated tagging. So this should be very interesting to see that. So we'll turn it over to a video presentation. So roll the video from Jean-Simon Venn.
So hello, everybody. I want to talk to you today about optimizing energy saving in order to improve comfort with AI and with the Haystack tool. And more precisely, we'll show you how did we automate the Haystack tagging process to accelerate our scaling capability. So I want to talk to you about, first of all, what do we do at Brainbox? Quick introduction on our process and how automating tagging making sense for us. And it's a tool that we call Autobot. So we're going to show you how it works. And at the end, just show you briefly the kind of benefit that we extract from that automation. Artificial intelligence make car autonomous. Brainbox AI make existing HVAC system autonomous. That is what we do as a company. And our process at a very high level is composed of these 4 steps. The first step is we need to either download a Tridium driver if you have a Jace or a Tridium platform, or we need to go into install an edge device. And that is a process of installing that edge device to the existing control system, which then bring us to the step number 2, which is collecting the data from that existing control system for a period of 6 to 8 weeks. So the deep learning AI engine could start to learn the building and become very acquainted to the building behavior. And from that, we move into the step 3. So having that deep learning engine now completely customized to that building, we are able to predict what will be happening in that building and start to optimize and eliminate events that are undesirable. So optimizing the energy, but also helping on the comfort side. And that is bringing us into step 4, where the engine is through the edge device or the Triton driver is controlling the building, which is optimizing the building in synergy with the existing control system. So the two systems kind of merge together and add another layer of intelligence to the existing control scheme of the building. And that is usually giving us on average up to 25% energy reduction, decreasing the footprint in terms of carbon emission, depending on how dirty the kilowatt hour you're using. Is more dirty or cleaner, you're going to move in between 20 and 40% decrease on that footprint. We usually eliminate more than half of the a bit too hot, a bit too cold events, or increasing the comfort of the occupant. And as I mentioned, the install is quite rapid. So since the start of the commercialization was about 24 months ago, and to be precise, it was will be at exactly at the end of this week, exactly 2 years that we started the commercialization of the technology. We're already at more than 70 million square feet installed in 17 countries and 60 cities all over the planet. This penetration and deployment is really accelerating right now as we're signing more and more partnership. And to give you an example of a new collaboration that we just announced this week with Belimo, where we're going to work together to develop the AI for their different valve system and increase the footprint from our technology, and also help them to basically sell more device. So when you look at the detailed process of deploying this AI in building, it really developed in 5 different big steps. And I'm just going to focus, because we're really limited on time during this presentation. I'm going to really concentrate myself on the data mapping, which is the second step, which is composed of things like point filtering, Haystack tagging, and the power tagging. So these are the special tag that give us the energy consumption of equipment. And this is where Autobot fits in. So we developed Autobot over the last 3 years with a partnership with the NREL in Colorado, where together we put together that piece of AI that we call Autobot, which is there to automate these 3 steps. So it's done completely automatically with the supervision of a human. That's the step that used to be done completely manually. And how do we do it? Well, it's really, we receive these raw point name when we connect to a building, which sometimes makes sense, sometimes don't. And we basically use these raw point name as the initial information that we're ingesting. And using that, well, we're basically start to decompose them. I'm going to show you in the next few slides how do we decompose them and how do we use K-mer to develop a common base that's going to be very, very important for us to be able to do the mapping automatically. So the first step we do, we decompose the raw point name in different keyword, and it's usually done as we decompose that raw name into different word. And we then basically put together the K-mer. We're using a base 3 for the K-mer. So we basically decompose all of these words in 3-digit segment, which could be meaning things like, if you look at the number 49, fan, so it's pretty straightforward, but humidity become a very complex K-mer vector. And it's that vector that we will use from a comparison base to referring to using a Haystack tag dictionary. We will basically try to rebuild what tag should we put to that vector. And to do so, we are using a random forest classification system, which is narrowing the search in each of the vector to eventually give us all of the tag that we should put. this is basically part of a unified architecture, which is composed of what I just show you in terms of the K-mer decomposition and also the random forest classification system. But to work, we need to do a data pre-processing to pull all the data from the source, to format that data. We need to perform the preliminary cleaning. And then also we need to put all of the model and the parameters, so we should be able to figure out what is the exact time series and a pre-processing method that we want to use. Once the K-mer and the random forest job is done, we basically get tags associated to each of the raw point name. And then we need to do the data post-processing, which are basically cleaning everything up. And we're using that data, which is an output, to train more models. So we could have an enriched database and have better precision the next time we're going to run another building. Show you a bit of the results. We tested at that first and very small retail location. So think about 100, 150 point per retail location. So usually rooftop type of setup, very simple to tag, but that was a good base to start. And you see here the Autobot results giving results in between 80 and 90% accuracy. So there's still some point where we're not able to name automatically, and that's why we still need a human. So that's basically spitting out an exception list that a human will do the tagging manually. Then that was tested on a bigger building. So think about 350, 400 points, more different type of equipment. So a more complex tagging situation where still we're getting a good 75% of the point being tagged. And you see here basically the output as we're having on one column the raw point name, and then the tag that were associated with that point automatically. So on our side, it's really a question of scaling. It's really a question of saving time. So being able to filter the point, that is a time-consuming task on our side. So now saving about 60% of the time that was spent on that task. The tag themselves, being the tagging, 75% saving of the time that we used to spend to do it manually. Power tagging is still in development. It's more complex, so it's only 30% of the time, but still it's 1/3. And it's giving us that scaling. So now we're reducing the number of time that it takes to deploy the AI in a building, and we're accelerating the pace. So I would like to thank you, everybody, for attending this quick session on how did we automated the tagging. We're using the Haystack and the AI put together.
Well, thanks to Jean-Simon for that presentation, and really shows how you can exploit Haystack tagging. Well, we're going to continue on. Our next presentation is by Shilpa Basapa, Associate Director of Engineering at 75F, and it is on the subject of portfolio-wide analytics with Haystack. So, Shilpa, as soon as I see your slides up, I'm going to hit the timer.
Thank you, John. So I'm going to start off regarding how 75 you're using Haystack. We are a complete BMS smart building solutioning company. So my first introduction will be what all it is that we do in our company. We are a complete vertical integrated system where when I say that, what I mean is that we have our own sensors, actuators, we have our own building automation system, with our own controller. We have our optimization data which is getting written into our cloud. We have our user experience apps, which allows the user to see them and use them. So how do we do this? We usually have operational efficiency that we maintain within the system and occupant experience, which is paramount and for us to be maintaining within a building. So in order to do this, we have our sensors, our edge devices, our controller, all working together, all writing data seamlessly to the cloud. We have applied AI and machine learning that is going to help us make predictive decisions regarding how the building needs to be instead of being proactive about it. So we use this computing in order to save energy with appropriate scheduling that happens, appropriate control that is given. So 75 saves around 50% of energy with almost 10% of occupants experience improvements. We're a complete BMS solution when I say that we have HVAC, air quality control, energy management systems, lighting. We also have remote visibility, manageability, automation, Bacnet integration, and also Modbus integration. So any equipment that is with Modbus, we will be able to monitor them and control them as well once integrated into our system. So how do we do this? We have all the data coming in from our sensors. Once it is come in, we have Haystack data formats that is written in. It's all written into the cloud along with weather data. All of these once put together, we have our smart algorithms that keeps churning, that has all smart decisions being made. Once all these tag data is written, all of these is sent into our controller and all the equipment on the building is controlled. So we at 75 are open to all third-party integrations. When I say that, what I mean is that we can be integrated with any existing BMS, IFMS, any enterprise command centers, or any smart city platforms, all via Bacnet over IP integration, integrations using any APIs, integrations with any BMS Modbus equipment. So now for the demo part, I'm going to show you the real deployment that has happened in some of our sites and how our data tagging and modeling is. So we've been speaking about data interoperability and digital twins. So this is one of our network charts. I hope all of you are able to see this. So this is the amount of data that we have for one building. So in a building, we have all the sites, all the zones, all the systems that's deployed along with all the points. So I'm going to just zoom in so that all of you are able to see one of our edge devices and all its points. So if you see here, we have desired temp that is here. We have sensor, which is pressure sensor. We have another sensor, which is, we have thermistor input that is coming in. We have current temperature here. So all of this is something that is already paired with the digital twin, and all this data is in the cloud. So this whole derivation of the data, if you're able to see, is from the digital twin that is created for the real equipment that is there in the building. So for apart from this, when we are doing tagging, one of the examples I would like to give is that we have this Explorer. For people who are familiar with Bacnet systems, you are already used to the Bacnet Explorer. So this is very similar to that. This is one of our sites. So we have our deployed system. So there are a lot of tags that are there. So you're able to see all the tags that is there for each point, that is there for each equip, for each site that is there. Let's say I want to find the current temperature for all the zones in the system. So I should be able to find it. So this Explorer really helps us find all the current sensors that is there. In fact, I just searched for current. So I think even the CO2 sensor and humidity sensors came up. So I'm going to say current temp. So you'll have all the current temperatures that has come up. We also have some current temperatures at the system level. So even those have come up. So this is our Explorer we currently have, which we use. Apart from these two, I would also like to take you through some of our floor plans that is deployed in one of the buildings. So once the floor plan is deployed, we have a lot of zoning that happens. So you can see all the zones that has been put in. And for each of the zones, once we get into the zone, we'll be able to see a lot of analytics over it. So all the analytics currently that is created is through all the tagging system that we currently have. So I'll allow for each of the profiles that we have some of the system graphs. At the same time, we have a lot of analytics that is based on tags. So for each profile that we deploy into a system, we give users predefined widgets so that monitoring to them becomes extremely easy. So they'll be able to monitor any parameter within a building that they would want. In case the user is interested to know more, get to compare things within a building, he'll be able to do that along with analytics. For example, I'm going to open up and show you all one of the widgets which we can configure. So let's say I edit in a building. Currently, I'm trying to build, we have supplier temperature. We have used WAV, GPC 36 for WAV profile. So we have trim and response logic that is running. And if there are parameters that we would want to monitor within this, we will be able to bring that up. We'll be able to plot it and we'll be able to monitor that. So if you want to see how this query tags and querying happens, we in fact can switch to the query format and we'll be able to see how this is done as well. So if you see here, you can see that our outside air damper is opening up. You can see that the cooling loop map is increasing and the outside air damper is opening up. So that is how you'll be able to monitor. So at some point, let's say I want to monitor things in more detail. Let's say we want to see what is the memory that is there in the current device that is running on the site remotely. So you'll be able to plot those devices as well. I'll give you an example how we could do that. Let's say I have 3 systems. If I'm running 3 systems, let's say I'm going to search for my diagnostic points. So I have all the diagnostic points that is coming up. I'm going to retrieve all the points that is there, and I'm interested in all the available memory or probably the Wi-Fi signal strength that's there. So let's say available memory. So I'm going to plot all of these 3. So I should be able to create a visualization. I've added it to my 3 systems. So once I bring up the system, you'll be able to see the widgets that I added. I think I've added quite a lot of widgets, but everything that I've added will be coming up here. You'll be able to monitor those. So that is how simple the analytics on our app has become once we have introduced the tagging part of it. So the Haystack normalized data that is there, once it's written into the cloud, we are able to create a lot of applications. So that makes it extremely easy. Another part of analytics is we also will be able to do a lot of energy analytics, where we'll be able to monitor and plot a lot of energy savings that happens within the buildings. So each of these widgets have been created accordingly. So let's say the user also wants to monitor multiple systems across multiple buildings. So the user wants to monitor all the current temperatures across the building. Currently, I've chosen very few zones where I want to monitor it. He will be able to choose a bigger scope. Let's say he wants to monitor it across 3 of his buildings for which he is a facility manager. He'll be able to choose all of these 3 and monitor all the current temperatures at the same time.
And you can tell what that sound is. That is the sound of the 10-minute timer. So
yeah, I'm almost done, John. So thank you.
All right. Well, thank you so much for that. Really interesting presentation, Shilpa. All right. Well, let's continue on. Last, but definitely not least, our final presentation today is from Alper Uzmesler, Managing Partner, BAS Services and Graphics. And the title of his presentation is Edgy Haystack. This is a recorded presentation, so roll video for Alper Uzmesler. edgy Haystack.
Within the few years, we've been working on Haystack from edge to edge cases, and we believe that this application would show that in full. So what we have done is we have written a mobile app that can read NFC, and we are creating Haystack tags to do certain actions by utilizing these systems. So first of all, we would like to demonstrate what Mobilytic is. On the right-hand side, you're seeing the Mobilytic login screen. On the left-hand side, we are seeing Mobilytic Dashboard Builder. There's no widgets assigned, so the concept is that you add the widgets on the browser side, and when you refresh, those widgets appear. And within this application, what we are doing is we're using Skyspark to evaluate Haystack and map the data to the widgets. The next app is the schedule app. We can basically manage the schedule model right within the mobile application, and we can see and add and remove different parts of the schedules. The next app is the Spark app. On the mobile side, by utilizing Haystack, we can basically look at Spark results and show and filter targets and filter rules right from the mobile application within itself. You can go back in month and change the queries. The next app is Browse app. This is basically a cluster-aware application, which is in Skyspark. And you can basically go to an equip, look at it monthly. You can filter points, and you can look at different parts of the application, like your ARC nodes, CMMS nodes. You can see basically the real-time data right from here. You can filter out Spark rules just on that given equipment. Right now, we are going to get a screenshot of the barcode. Each device has a barcode which has the rec ID of that equipment. We will get back to this in a second. Right now, just know that there's a barcode in there. The next app is work order ticket management system. So what we have done here is that we can basically create a ticket, and we can fill in all the parts of the ARC node right from the mobile app, and we can assign it to an equipment. We're gonna select Gatorsburg RTU1, and we're gonna select due date. And the cool benefit of having a mobile app is that we have camera built in, so you can take pictures of anomalies or issues that you see. To simplify for the user, you can basically create comment notes, get them to focus onto that area of the photo, and this is basically all built in. Once you save, it will basically save it into the applications directory, create a record for it within Haystack, so it is all managed within the Haystack model. Right now, the comments are, when we generate the comments, they're saved as the fandoc documentation within the system. As you can see, you can change the colors of your notes to make it easier for the eye. So once we look at on the left-hand side, we will refresh the application. What you're going to see is the ARC note that is created, and you can see the notes within there. If you remember the barcode app, now what we're going to do is scan the barcode. It will take us to that equip, and you see that that filter, dirty ARC node, is just been added to the system. So Nfc actions are really interesting. We can do a point write, meaning that we can change set points. We can do a his write, meaning that we can write to the historical data of a point. We can create result and comment arcs with these NFC chips, and we can create records for easy provisioning. Like if you have an indoor air quality sensor that you want to map it to your system, you can create the records automatically. Here's the screenshots of how that works. We have an NFC tag, and it looks for a tag, and then if it finds it and is successful, it will just give you a feedback of what it has accomplished. The other side of the spectrum of the edge is the controllers, the equipments. So the controller EAC V1, we have built these EAC IAQ, and we have EAG Modbus. The Modbus device has isolators on it for the RS-45 ports. They all run with Project Senstar. So Project Senstar is basically in electronics boards. There are protocols like I2C, UART, GPIO, SPI. So there is a Senstar engine. The engine's goal is to be a bridge between Haystack and Sedona framework. Within Sedona framework, there's a SOX protocol, and I will get back to this in a second. And also within Sedona, we have written Project Haystack client, which would mean that we can actually make data calls to another Haystack server. In this case, we are utilizing Oncolytic, which is powered by Skyspark. On the other side of the SOX protocol, what we have done is we have written a WebSocket conversion application that runs within Skyspark. And all these applications are running within individual controllers. And also the Project Haystack is basically mapped to client is mapped to server. So there's like a mirror effect, and the Haystack server, which passes the points on Senstar points, is consumed by a client within Oncolytic. In Skyspark, there's the ArcBeam protocol, and the ArcBeam is basically a secured method, and you don't need to have IT involvement. It's a WebSocket protocol. As soon as you have it, it basically establishes dual-way communication. So it opens up a channel. And it's one of the parts that it does is it basically enables Haystack server-client relationship between two different nodes within itself. And what we have done is we have gotten some APIs, and those APIs we were able to write Senstar SOX proxy. The WebSocket conversion that we did for Sedona, we were able to pass it into the master instance, so that we can actually, not only that you can program your Senstar code within direct IP, we can also program that through clustering. So what we have is a project instance. If one is in Austin, the other one is all the way around the world in Turkey. We have Oncolytic installed, which is a Skyspark instance. That is the edge device is clustered northbound, so it's clustered actually to Austin. And once we have that communication, we have a device that is running Project SenStar, and it is an indoor air quality sensor. So we can we can program the LED lights on that application. You see some LED lights written here. We can actually program those through clustering. So let's go through how SenStar Web Editor works through clustering. So what you're seeing is a project of 3 different indoor air quality sensors installed all the way around the world. And we can see all of its data. We can see all the information from the indoor air quality sensors. This is basically clustered to our instance in Austin, Texas. So what I'm going to do is I'm going to go into one of these indoor air quality sensors, and we're going to look at some of the data in there, and we're going to go into the SenStar Web Editor through clustering. So this data is loaded to us through clustering, no firewall or IT involvement within this application. So we're going to look into COVID dashboard. This is basically SARS heat map calculation based on Homeland Security. We have created some views. This is basically a Haystack connection. So we are in the device, and the device has a local host 8085, and we have Haystack points that we are reading through SenStar. We are converting UART protocol into Haystack values. Now we're going to get into SenStar Web Editor, and we're going to see how that logic looks like. So JavaScript and HTML is loaded for us. And when we click on the tab, it loads the WebSocket. So UDP gets converted to WebSockets, and WebSockets are sent to us in a secured manner. By the way, we are in HTTPS and secured WebSocket communication. So any data that is going through is encrypted. So what you can see now is that we can read the inputs, the readings live in the block programming fashion. So all the data that you see here is literally live. And not only that, we can actually program any part of the application right from here. So we can right click and you will see all different kits that are installed within this application, and we can program it from here. So what we are going to do next is we are going to go into the host, and we're going to look into the master project and how that is laid out. If you look at the builder, there's only a single site and there's nothing else. So what is happening here is a dynamic navigation is being generated for us to look at all this data. So this is pretty much it on the SenStar Web Editor. And the next part is basically, we have the ArcBeam technology that is communicating from the edge device to the master cluster. And what we can do is we can build a lot of different tooling around this. So a few of the things that we have done is we created a provisioning tool. So what this does is it basically allows us to upgrade Skyspark through clustering. So once you select a clustered node, it will look at which version it is on, and we have a secured package that is utilizing a cloud service. We can download that and deploy that to the edge node. It is very similar to how we operate our cellular phones. The next application is Cluster Extension Manager. If you wanted to enable a module through, or if you had 100 of devices, it would take a lot of time. You could write an Exon function, but what we did is a simple view that you can enable it. The other one is basically updating modules. So within this app, what we are doing is you select the module, and the application goes and looks at all the instances of that given module name and what is available on StackHub. And you can create a task, and you run the task, and it will restart Skyspark. It will install that pod, and so on and so forth. So this is basically extension managed. So you have is runtime backup server. So we can have multiple devices that is on the network, rooftop unit feeding to VAVs, and you have SenStar in all of them. What we have is a single button to create a backup of the whole application. So you can basically select them all and say backup all, or you can select individual. And what this does is it utilizes the ArcBeam to pass data from edge nodes to the master node securely. And then we can back it up from there. The next part is deployment templates. So we have unit schedules, and we can add tags to the devices on this view. So what we can basically say, these are RTU cool only. What this does is it actually adds a tag on the project as a SenStar template in individual device through the ArcBeam. And now in here, we have deployment query, and then you can search based on this tag on these devices, and we can hit deploy template, and we have basically a backup source on the last project that you worked on, and it will deploy it. We also have limitation on how many backups you want to keep per instance of the application. So the next application we got is Firewall Provisioning. Firewall Provisioning has 2 different apps. One is client, and the second one is the provisioning. So the client is all the rules that are defined via through cluster or within the local instance itself. And this rule is for outbound firewall rules, meaning that the device will only be able to talk to these IPs and ports. In order to have a dynamic DNS, we have made it so that we ping certain domains and you can find their IP as well and update it as well. So if an IP changes, these edge devices are smart enough to figure out what the new IP address is. So the second part is the provisioning server. What you're seeing is a number of clustered devices and how many of them are secure. This is basically in our dev environment. And basically from here, we can create rules for outbound firewall definitions as a template, and we can deploy those to the clustered instances from here. So you create your definitions for firewall rules and you deploy them through this. The last and not the least, we have a point shop that is utilizing Haystack. You can basically create a new order, update a license. It utilizes Haystack in full in order to update the license. So looking back, we have basically manipulated with Silicon and Haystack. We touched all the way to the metal. So we have basically edge-to-edge Haystack, end-to-end Haystack in a secured way. Thank you.
All right. Right to the wire, right to the wire. So, all right. Thanks, everybody. Well, thank you, Alper, for that presentation. And finally, thanks to all of our Pitchfest presenters. You know, every year it's amazing to see what the community is doing to advance Haystack technology, but also here you can clearly see how they're leveraging it in products to create more cost-effective products, more feature-rich products, control systems, software applications, all to serve and advance the performance of the built environment. Well, that concludes Pitchfest for 2021.